Have you ever wished you could just have a conversation over? You know, a first date, maybe a job interview, or just that one perfect moment with a friend? Well, we're going to dig into why that's not just a little difficult, it's actually mathematically pretty much impossible.
Okay, so let's just start with this question. I want you to really think about it for a second. Have you ever truly had the exact same conversation twice? I mean, word for word, same timing, same pauses, same jokes, everything.
You might get that weird feeling of déjà vu, for sure. We all do. But the thing is, according to a new mathematical model, a perfect, identical repeat of a conversation isn't just unlikely, it's so wildly improbable that it's, well, impossible. So how can that be?
Okay, let's get into it. This isn't just some gut feeling we have. It's something science is now actually able to measure.
And it all comes down to something called the temporal combinatorial model, or TCM for short. It's a bit of a mouthful, I know, but the idea is actually pretty straightforward. It proves that every conversation is unique by looking at two huge factors. First, the insane number of choices we have when we speak, and second, the simple, unstoppable arrow of time.
So let's tackle that first part, the wall of words. This is where you start to see just how gigantic the landscape of conversational possibilities really is.
The fancy scientific term here is combinatorial complexity. But don't let the name scare you. The formula itself looks simple enough, right? You just take the number of choices you have, we'll call that K, and raise it to the power of the number of words in the conversation, which is N. But trust me, behind that simple little formula is a number so big it's hard to even comprehend.
Let's try to get a handle on this. Think about just one of those choices, the words you use. An educated adult has a vocabulary of around 100,000 words. So for every single word that comes out of your mouth, that's one choice out of 100,000 potential options. And that's not even counting your tone, your pace, your body language, all the other choices you're making.
So what happens when you do the math? Well, for just a short 100-word chat, the number of possible ways that conversation could go is 10 to the power of 100. That is a 1 followed by 100 zeros. Now, to put that into perspective, scientists estimate there are about 10 to the 80 atoms in the entire observable universe. So yeah, the number of ways a tiny conversation can unfold is literally bigger than the number of atoms that make up reality itself.
The researchers who figured this out have this awesome name for it. They call it the vast phase space of possible conversations. It's like this infinite, unexplored territory of everything that could possibly be said. So right from the start, we're dealing with near infinite possibilities, which makes a repeat almost unthinkable. But, believe it or not, that's only half of the equation.
Which brings us to our next section. Time changes everything. Because even with all those choices, it's what time does to us that really seals the deal.
The model calls this temporal decay. It sounds technical, but it's a powerful term for a very simple truth. You are always changing. Every second that goes by, you're learning things, you're feeling things, you're experiencing new stuff. The person you were a minute ago is already gone. Never mind the person you were last week.
I mean, just think about yourself today versus you last week. You've read new things, you've had different worries pop up, you've lived through countless tiny moments that have shifted your internal state. For a conversation to be a perfect repeat, both you and the other person would need to somehow rewind your minds to the exact same state. It's an internal context that just decays with every single tick of the clock.
Okay, so let's put it all together now. Section 4, the impossibility formula.
So here it is, the whole shebang. The probability of a repeat over time equals 1 divided by that colossal number, omega, we just talked about, multiplied by this other term that just represents decay over time. So in plain English, you start with an already impossible chance, and as time moves forward, that chance just gets smaller and smaller and smaller. And this is where the numbers get truly mind-bending. So, the instant a 100-word conversation ends, the odds of it repeating are already 1 in 10 to the 100th. But just 1 week later, those odds absolutely crater to 1 in 10 to the 131st. They don't just get smaller, they fall off a cosmic mathematical cliff into nothingness.
And there's one final twist here that makes it all even more impossible. It's a feedback loop. Every single conversation you have changes you. Your perspective shifts, even in tiny ways. That alters your internal state, which then guarantees that all of your future conversations are going to be different. The very act of communicating is what prevents perfect repetition. It's wild.
So, okay, this is some pretty heavy math. But beyond the numbers, why does any of this uniqueness actually matter? What are the real-world takeaways here?
Well, this model has some huge implications. For anyone working on AI, it shows just how monumental the challenge is to build a chatbot that can truly seem human and evolve with every interaction. In forensics, it provides a mathematical backbone for the idea that conversational evidence is unique and can't be replicated. And for social theory, it gives us a real formula for something we've always known intuitively, that time is an irreversible force in all of our relationships. So when you boil it all down, the ultimate takeaway is this. Every single conversation you have, every chat, every argument, every laugh is a once-in-a-universe event. It is guaranteed, mathematically, to never happen again. Every interaction is precious and totally unrepeatable. So the only question left, really, is what are you going to do with your next one?